How to do, everybody? And also, thank you to Seth, and you're making me very nervous when you started calling my name 30 minutes ago. Like I said, I'm kind of finishing the talk right now. And also good news with that, I doubt I'll fill my whole 40 minutes, so we'll get to the coffee break early. So introducing myself, I'm Morgan Allen, longtime professional programmer, about 20 years experience. I started as a front-end developer 20 plus years ago, a lot of JavaScript and web design. About the last 10 years, I've been mostly exclusively a Python developer, focusing a lot on back-end and specializing in Django projects. I've also been a long-time fabricator, including I worked for many years as the lead exhibit fabricator at the Chabot Space and Science Center in Oakland. And it was during my work there that I really started pushing my use of FreeCAD, jumping into a lot of the internals, programming, scripting. FreeCAD uses Python for its scripting interface, and doing a lot of CNC work as well, using the Path Workbench, now called the CAM Workbench, and some minor contributions, particularly to the CAM Workbench. Today I'm going to talk about KiConnect. It's a FreeCAD workbench that utilizes the new KiCAD 9 API to do interactions, bidirectional interactions between FreeCAD and KiCAD. See kind of a demo running in the background where you can see edits going on, and the far right there is actually KiCAD in the background. You can see that updates work in both directions. Bit more about, like I said, I've been doing fabrication with FreeCAD for a long time, particularly a lot of CNC work. I am an enthusiast of beverage assembly robotics. This is called the Barback 2.0. This was completely designed in FreeCAD, CNC'd out. It's been fabricated and it's made entirely out of plywood, designed in FreeCAD and CNC'd as well. So all the G-code generation is done in there. And had the great pleasure of attending Robo Exotica in Austria last year, and we took a pair of the barbacks and had a really great time with that. Then general FreeCAD, additionally FreeCAD ecosystem. I also work on a project called the FreeCAD Parametric Web Viewer. This is a website that I'm building to view FreeCAD models, being able to present your work to clients was the particular motivation. But unlike your 3D printing websites, printables and older Thingiverse, this one actually extracts parametric information out of your model and allows you to do updates on the fly. So things like the SMD reel, you can define all of your diameters and how big of a reel you want, export as an STL, and do a 3D print. Had high hopes to release the new version of this before the conference, but we didn't quite make it. So next couple of weeks, this will be being released. My motivation behind KiConnect, I'm not a professional PCB designer. I've been a hobbyist for a long time, and I tend to make weird and unnatural circuit boards. 2018, I decided to build the ultimate shrine to dying batteries. This is called the Cacoffiny. It is a 13-piece PCB, and it actually is about 13 millimeters. It's exactly 13 millimeters deep. It has the LEDs that you can see are shining downward into it. So all but one of the 13 boards have some active element on them. The front bezel has LEDs shining in. All of the side pieces have buttons, and it was a highly interactive badge. This was, obviously, I designed this in FreeCAD and KiCAD. And as this project progressed, I kept finding myself backed into a hole where I wasn't able to make updates that I wanted, particularly when it came to panelization. So as the boards got panelized together, I was really stuck where I couldn't make major changes to the outline because then I had to repanelize, and things weren't working out. And in fact, I spoke at the first KiCon in 2019 in Chicago. Where did we go? What are we doing here? Oh, come on. There we go. Oh boy, we're not going through this whole talk. Sorry, everybody. We're gonna hit refresh. So my 2019 talk was about the headaches in which went into doing this design and a lot of the shortcomings in this process and where I wasn't able to do the things that I wanted. And as part of this talk, I made a threat that I was going to come back one day with tooling. And I've several failed attempts. Due to particular limitations, I never was able to really build out what I wanted. I got some things working, but just never like the complete package that I wanted. And so with the release of KiCAD 9 and the new API and an API that could be relied on going forward for consistency, the time was right to take another crack at this. So in FreeCAD, if people have not used FreeCAD before, it's made up of workbenches designed to focus on one aspect of work. I've already mentioned the CAM workbench that I use a lot. This is to take your 3D models and produce G-code for a CNC, or maybe even advanced 3D printing. There is architectural workbenches that follow international building codes, so you can do legitimate professional architectural work with it. There are workbenches for, what other workbenches do I use? Several different ways to do solid modeling. They're all written in Python for the most part. There are some facilities to write C++ add-ons as well, but for the most part, you can accomplish most functionality with just a Python workbench. Workbenches are largely split into two parts. One aspect is to actually control your objects that you're generating, and then the other part has more to do with how things are displayed. Do you want wireframe? Do you want shading? And that part's not actually used that much. And then there is a very powerful feature built in. They're called Python features or Python feature objects. And these are programmable entities in your model. And the KiConnect utilizes this heavily. Customized sketches for their outlines, API connection to KiCAD, and just the overall control uses many different Python features. You can have customized groups, customized sketches, custom parts, and they're all generated using Python. And under the hood, this is what is being used. Prior to this, there were some facilities to do this before. None really worked out for what I was trying to do. And effectively what I was stuck doing at the time was just importing and exporting outlines. And when going from a three-dimensional assembly in FreeCAD to a panelized board in KiCAD required a significant amount of manual intervention. I attempted to automate some of this stuff with customized footprints that would signify where a bridge would go. It was very delicate. It was a process that didn't work all that well. Anybody who has used FreeCAD in this method has used KiCAD Step Up. This is workbench that's been around for many years. A lot of powerful features, too many features, I think, in some ways. And it has some inherent problems. They ship their own parser, so they're actually parsing KiCAD files themselves, which is error prone because every time there's a new release, and particularly releases of 8 and 9 where many primitives were introduced, things like arcs and circles and rectangles, rather than just line segments, required a lot more parsing. So updates, thankfully the team there is very responsive, but it is still an error-prone process. And that's kind of it. There's not really a lot of other options right now. So again, like I said at the beginning, with the release of the new API, I thought it was a really good opportunity to really jump back into this project. So from the website, the KiCon, why are my slides not updating? KiCAD Python project is a set of Python bindings to the KiCAD IPC API, officially maintained by the KiCAD development team, and a huge shout out to John Evans, who is doing a lot of this work. Yeah, basically wouldn't be possible without. John's been incredibly responsive too for helping me directly getting some features rolled into this to make this workbench possible. Simmer down. Prior to the new API, we had the KiCAD Swig API. And if anybody has used this, you'll understand that it is also problematic. Shares a lot of the problems that KiCAD Step Up had, where with new releases there were unexpected changes, particularly because Swig bindings are auto-generated. So you're not, with every release, you're not quite sure what the API will look like next time. They're also Python only, and already now there are at least two bindings that I know of. For the version 9 API, there's the Python API that I'm using, and even prior to that, I believe the first one was a Rust API. And then, yeah, just inconsistencies, and this is about the how every release came out. These APIs were auto-generated, so you have issues with things changing in unexpected ways. There's been a couple libraries out there that have attempted to address this through version checking and creating a consistent API on top of it. These are also not without their problems, because with every release they need to update and make sure that they're actually working. So there's a general theme here. I like Python. FreeCAD likes Python. KiCAD likes Python. So bringing everything together, Python all the things. And that's really working well for what I'm trying to accomplish here. So KiConnect, there's a very pre-release version of it out right now. A lot of this talk is for a call for support and call for people to look at it early on. Again, I'm not a professional designer. I have niche features that I'm after, but I would really like to broaden the feature set to bring it to a more professional audience and just make sure I'm providing features that are actually useful to a broader community. So with that, I've got what works. So importing board outlines, as you saw that background demo earlier. Pulling in board outlines was the first feature. It was surprisingly easy to implement, and really got me motivated, got the ball rolling to continue with this project. Footprint pads work, pulling out copper pads in particular was very straightforward. Again, just very easy to set up in FreeCAD as well. We can import the actual 3D models for everything. And I can push outlines back into KiCAD. Slight caveat there right now. The Python API interface the current release does not work to do this, but when the 0.4 release comes out, all of the current bugs are fixed in that. So hopefully we'll see a lot of that coming out very soon. And especially with the KiCAD 9.0.1 or 0.2, I think, fixed several bugs on the back end of the API. This is kind of a broad demo showing much of the features. It's a little bit dated now, but shows off. There you go. All the parts. We see copper pads. It's very fast. The slowest part of this is actually importing those 3D models. And then we can see we've got all of our references to our parts. Here is all of our individual nets. And this is a place that I'm really interested in getting feedback in, is how does it make sense to lay these sorts of things out? Do you organize things by net? Do you organize things by individual pad? There's a couple different options, including being able to view them in multiple different styles of view. Where are we going next? Okay, so current limitations. So as I said, this is very pre-release. There's a list of issues that are probably about equivalent to the lines of source code. Not quite there, but and then the great thing is like a lot of these problems are very solvable. There's known solutions to many of them. They just haven't been implemented yet. I'm trying to go for broad surface area at the moment to really get that initial feedback. So limitations are I'm only supporting polygons at the moment, which from what I've seen, many people have not moved to polygons yet. A lot of line segments. Again, solvable problem, because I believe the polygons weren't introduced till 8, maybe, I'm not quite sure. Solvable problems, taking line segments and organizing them and turning them into polygons is doable. There's nothing really there. Same for internal cutouts. I just, bounding box checks, there's nothing crazy about that. I am extracting tracks as well. And they just need their lines thickened. So things like that. And then back to back to what I was saying earlier, pads and tracks are there, but I'm not quite sure what the best way to organize these things is. So that's a big part of where I'm looking for community feedback and just early eyes on this project as I move forward with it. General broad plans. Again, like I said, I do kind of weird 3D stuff. So that's my goal. So multi-board support. That's a huge thing for me. There are currently limitations in KiCAD itself that make this difficult. Namely, you can't open multiple documents. I hear that's coming. Tabs are coming, maybe. There's going to be some support for that in the future, I believe. So that will ease a lot of that sort of development. And beyond my weird needs, I believe this is a legitimate professional need. If you've got multiple boards and you want to lay them out into a project, this currently can be done. I do support it already, but it requires you to open each of your projects and then import. And if you want to push back, you need to reopen that other project. So it does work, but it's a little bit finicky. And I'm hopefully not speaking too broadly or uninformed, but I've heard that the API, the KiCAD CLI at some point should support the API functionality. If that comes through, that's correct? Cool. So when that comes around, the idea is just to launch the CLI in the background. Do your imports and your exports that way. You won't even need KiCAD to be running if you don't need it. And then for the professional crowd, the thing that I really, really want to support is flex PCBs. So this is a huge underpinning part of multi-board is if you're doing an FPC connector, some sort of custom flex connector in between boards. FreeCAD already has a lot of facilities built in. There's a curves workbench built in, and then there's another one called Surface, and these are both for working with non-planar three-dimensional surfaces. So those are the sort of things that can be utilized to do the Flex Connect style of stuff. And not on the list here is another thing. I've already started dabbling a little bit with panelization built into here. This is one of my big goals. I'd like to work on something in a three-dimensional aspect and then be able to just switch views, and it's flattened out and it's panelized. If anybody's used KiCAD for panelization before, that also written in Python. So my plan is to integrate that into this workbench, licensing, compatibility, permitting. This is also licensed to GPL2. That's a requirement to get anything included into FreeCAD. So that's the license that will be used going forward. And that's kind of what I got. I'm about 10 minutes short, but I think that it summarizes kind of what has been going on here and what my plans for the future are. And, with everybody's feedback, I think that this is an opportunity to build a really great tool going forward. Now we can get questions.
I don't generally do the ECAD to MCAD so much because the tracks, don't work very well.
Sure.
Most export well if you're looking at particular layers, copper layers. Like for test pad points for mechanical alignments. For the bed of nails. That's helpful. But from a visual, especially going to MCAD, just the look, with silkscreen is awesome.
Sure.
And just the test pads in terms of test points. Yeah. I don't really need. It's great that you did the component test pad. Pads in general, but that's kind of sort of unnecessary, perhaps. So I would think silkscreen is
sure
should be.
So generally, the comment question is the lack of silkscreen, and that's just not implemented. There's not. Again, this is a solvable problem. The information is all there. I'm already doing extracting information and drawing outlines. So that's just a very doable. Again, I'm going for broad surface area first, just trying to get a lot of the functionality done. It's on the list, and it's not a difficult thing to implement. And then about parts, for me, parts clearance was very important. So that's why pulling in the 3D models is critical, because then you can, in your MCAD design, you can see those clearances. Bed of nails sort of thing, pads are already being extracted. So you can just reference those. FreeCAD has a concept called the shape binder, where you can be working on one solid or one body, and you can reference features in another one. So in something like that, you could go into your combo view, the hierarchical tree, select all of your test pads, hit shape binder, and now you've got a virtual connection. The really cool thing about this as well is that they automatically update. So if your test pad gets moved around, it will automatically reflect in your new body. So your bed of nails will basically always be up to date.
Thanks.
Yeah.
Do you have in mind that the tool either is mostly now or will become usable without Python programming directly, or is it intended to be a tool that a Python proficient person would operate?
Nope, it's just written in Python. yeah, ideally nobody would. No, you would never have to use Python yourself. But one of the really neat features of FreeCAD is you effectively every line of Python is run on its own, and you actually get a log of everything that's happening. So let's say you wanted one really small part of what I'm doing. You can pull that out and write your own macros, is what they call them in FreeCAD. So you could write your own macros to use very specific parts of the workbench, but it's absolutely not required. So up in the back? No.
So you said that you do support multi-board, but on the KiCad side, it involves multiple instances or multiple imports. On the FreeCAD side, are you using the assembly workbench to assemble these, or are they just individual bodies that you shift around?
As of now, they use what's called the attach extension, which is the basis for assemblies. But the idea, I want to be assembly agnostic. So yeah, as of now, the parts, I had a demo here somewhere. Kind of relevant. So yeah, so there is a parts group, and that is like a virtual object. And then all of the parts within are using an attachment offset to localize themselves there. But within FreeCAD, and this was one of the big goals, and this is one of the, for me personally, one of the shortcomings for our KiCad Step Up was it's difficult to use the boards complete in another assembly. And from the very get-go, I was testing that, and I test in the new built-in assembly workbench, and then my preferred workbench assembly is Assembly 4, and I've tested in both of those. And the whole kit and caboodle, the whole board is able to be included in assemblies, including arrays. So if you have, like say you're doing something with a bunch of LEDs built into it, and you've got a small custom board, you can array those out. And then it works for all of the individual parts become their own linked references. And if you move one, so say you need to do a little bit of a tweak, you can move one, it updates the original that everything is linked to, and then you can push that back as well. Oh, and also a kind of a follow-up earlier about multi-layer. Right now, a board itself is a pretty abstract object, and I did that keeping in mind for multiple stack-ups. So a quote board could be just an individual layer. I think one way in the back there, yeah.
Thanks for the presentation. Looks like a really cool project. Any thoughts on using IDF or IDX files for broader ECAD, MCAD compatibility with other systems than KiCad and FreeCAD?
No. I actually don't quite know what a lot of that is, so yeah. No, and again, community, yeah. I hope to support a broad set of features, so that's if somebody were to come at me with a pull request, I don't say no to other people doing code for me.
All right, cool. Maybe I'll take a look. Basically, cool. IDF and IDX, they're interchange files that allow all sorts of ECAD and MCAD systems to talk with each other with cool. board shapes and component placements. Cool. So that might be kind of interesting.
Yeah, very. It sounds neat.
What is the relationship between KiConnect and the KiCAD step up to KiCAD? Is there? Do you have a relationship with Maurice, or exchange of ideas, or are you working completely separately on this project?
It's completely separate. I have some bug fixes here and there with KiCad with Step Up. I've used it for years. The one big difference is I have no intentions of supporting other APIs. I'm not going to go back to the SWIG. I'm not going to attempt to support 6 that some people are still using. Step Up has very broad support, and there's even talk they're going to start supporting 9. I don't intend to do any of that. I'm only going to use the API going forward. Yep.
Yeah, you kind of captured my attention with the bed of nails
Sure.
talk. And, the problem I'm trying to solve with that is I generate a board, it has to be manufactured. I need functional test, maybe in-circuit type test. Do you have any way to automate that? I don't even know how to approach what you've offered here.
Mm-hmm. Yeah, so like I mentioned before, there's something called a shape binder. So what you could do is you would select all of your test pads and you would make a shape binder for them, and that would be your test bed. Your test bed would be referencing the pads on your board. And what are you doing? Just vias to put your pogo pins in, or through holes to put your pogo pins into. And because they're a direct reference to the original test pad, anywhere that pad gets moved, that reference is always just updated. So in that case, all you would really do is maintain your board outline, put your test parts, whatever you've got, an IDC header or whatnot, to actually connect to your test system. And then you wouldn't mess with the test pads at all. You would just utilize that shape binder to always keep it up to date. And then I don't think people are going to be doing a lot of track manipulation in FreeCAD. I don't think it makes a lot of sense. So then that's the only thing you would really need if you made a drastic change. That's the only major update you would need to manually do. But hey, maybe we can call the auto router from the API. Everyone loves the auto router, right? But for something simple like that, that legitimately could work.
Do you have any documentation about how to get started on that?
No, the documentation right now is just literally build documentation. This is still very, very pre-release. Just really trying to get a feel for what this should look like, and particularly what this should look like to other users. Documentation will come. And again, you can't really use this right now just due to the fact that the KiCad Python API has several bugs in it. So until the next release comes out, this won't be really broadly supported. So it's very much in developer mode at the moment.
That last question was similar to what was online on the YouTube livecast. Alexander had a question related to, do you have any plans to have a screencast explaining how to use it, how to set up FreeCAD and KiCad, or some examples?
Yeah, so I've already got some examples built in, just kind of my daily testing, or as I'm doing development. I hope that this starts getting broad enough attention that that's those sort of things. Yes, doing some videos on how to use and doing better documentation is all in the pipeline. Yeah.
Okay, thank you very much, Morgan.
I almost made my full time. Thank you.